Good morning students. Welcome back for your mathematics class. In today's class we are going to study the fourth chapter, that is polynomial. Before going to start the polynomial chapter, let us know some basic terms and the definition here. Okay. In that the very first definition, that is algebraic expression. Here algebraic expression, it is also a mathematical expression. It is a mathematical expression that consists numbers, variables and operations. Operations are addition, subtraction, multiplication and divisions. Okay. So let's see some examples for algebraic expression here. Here, as I told, it consists what? Variables, right? Variables means x square, right? This is an algebraic expression, and we'll take one more example which containing variables, numbers and operations also here. 3x squared plus 1, isn't it? It containing variable, numbers as well as operation. We'll see some more example. 2z plus 3. Even this is also an example for an algebraic expression, or you can check subtraction sign also, right? These are the some examples for an algebraic expression. You can write some more examples. Here I have explained only 3 examples, right? So we'll write the definition for algebraic expression. Here I have written the definition, that is algebraic expression definition. An algebraic expression is a mathematical expression that consists of variables, you can see here variables, operations, addition, subtraction operation, and also it containing what? Numbers. Yes or no? This is an example which containing only variables, right? This is an algebraic expression which containing only variables, right? This is about an algebraic expression. Next we will study what is algebraic equation. Here algebraic equation, it is nothing but equating the given algebraic expression. Equating the given algebraic expression to a 0 or some real number. It is called what? Algebraic equation here. So let us take, as I told, it is nothing but equating. Here I will take an algebraic expression 3x squared plus 1. I am going to equate. Equate means equal sign to 0. Or you can say some real number here. This is what algebraic expression. We'll take some more example. This is example 1. One more example we'll take. Even x square is an algebraic expression or not? So I am going to equate this to a 0 or any real number. And third example we'll take 2z minus 3. Again I am going to equating this algebraic expression to a real number. This is what a definition of algebraic equation. I think students, these two definitions are clear for you. So, okay, next we will study the classification of polynomials. They have classified the polynomials on the basis of two conditions. First condition on the basis of terms, and second, that is on the basis of power of variables here. On the basis of terms, there are again 3 types. Those are monomials, binomials and trinomials. On the basis of power of the variables, again there are the 3 types. Those are linear polynomial, quadratic polynomial and cubic polynomial. This is how they have classified the polynomials. Let us study their definition one by one. First we will study on the basis of terms, means we will study all these 3 types one by one. First one is monomial. Here monomial means which having only one term. Let us define it mathematically. It is an algebraic expression which consists only one term. which consists only one term is called what? A monomial here, right? So let's see some examples for the monomials. Examples: x squared, first example, x squared. It is having only one term, right? Then second example, 3x squared. You can see 3x squared. It is also one term. Third one, we'll take x. Even x is also what? A monomial, which having only one term. It's having only one term. Such type of expressions are called as here monomials, right? So we'll write the definition for the monomial here. Okay, here I have written a definition for the monomial. It is an algebraic expression. You can see that algebraic expression which consisting only one term. Which consisting only one term is called what? A monomial here. Only one term, right? We'll see some more examples for the monomials here. Fourth one, even 3xy. It is also what? A monomial. And fifth one, we'll take minus 2x, which containing only one term. Yes? So these are the examples for the monomials. Okay, now let us see an examples for the binomials here. Bio means 2, right? It containing two terms, that is 3x squared and 2x are the two terms. In between these two terms, I am going to insert an addition operation, right? So this is an example for the binomial. Here you can observe there are the two terms. 3x square is one term and 2x is another term. So it containing totally two terms separated by the addition symbol. This is an example for the binomial. Then second example we'll take. y squared plus 1, right? Even this is also a binomial because 3xy square is one term and 1 is another term. Again it is separated by the addition symbol, isn't it? So then third one we'll see example 2x minus 1. Even this is also what? A binomial. Two terms are present, 2x and 1, and it is separated by the subtraction symbol, isn't it? This is also an example for the binomial here. Okay, now let us write the definition of the binomial. Okay, here is the definition of the binomial. An algebraic expression which consists only two terms is called binomial. Mono means 1, bio means 2, right? Now, next we will see example and definition for the trinomials here. Trinomial means, tri means here 3, right? An algebraic expression which consisting only 3 terms. Which consisting only 3 terms is called what? A trinomial here. Okay, we'll see examples for the trinomials. 3 terms. It consists 3 terms, 3x squared plus x plus 1, right? You can observe here 3x square is one term, x is another term and 1 is another term, right? Total it containing 3 terms, 1, 2, 3 terms. This is what? A trinomial. First example. Second example. We'll take minus 2x squared plus 4x minus 2, isn't it? Again it is containing 3 terms, 2x squared, 4x and 2 are the here 3 terms. These are what? A trinomials. Examples for the trinomials. These are the classification of the polynomials on the basis of terms. Here we have On the basis of terms, we have classified it on only 2 terms, 1 terms and 3 terms, as well. This is what on the basis of terms they have classified the polynomials. Those polynomials are here monomial, binomial and trinomial. Okay, next we will study some more classification, that is linear, quadratic and cubic polynomial. Before going to study these 3 types, next we will learn the definition of the polynomial here. We learned that if the algebraic expression having 1 term, it is called monomial. If algebraic expression having 2 terms, it is called a binomial. If algebraic expression having 3 terms is called a trinomial, right? Then what is polynomial? A polynomial, it is also an algebraic expression which consists more than 3 terms here. Which consists more than 3 terms. Such type of algebraic expressions are called as here polynomials, right? We'll see the examples for the polynomials. Polynomials example, that is 2x cube plus 4x square minus 2x plus 1. We can observe them here. There are 4 terms. 2x cube, 1 term, 4x square is another term, 2x is another term and 1 is another term. Isn't it? Here there are the 4 terms. If an algebraic expression involving 4 terms, then such type of algebraic expressions are called as here polynomials. We'll check some more examples. Second example, this is first example. 3x raised to 4 plus 2x raised to cube plus 2x square minus 2x. Sorry. Okay. 3x square plus 2x square minus 2x plus 1. Even this is also what? An algebraic expression. Sorry, it is also an algebraic expression which having 4 terms. So it is called as the polynomial here. Okay. These are the examples for polynomials. You can give some more examples, but here I have taken only 2 examples to define the polynomial. Next we will check the another type of classification based on the power of the variables. And also we denote the polynomial as, and it is denoted as p of x, right? This is the notation to denote the polynomial. It is read as p of x. How to read it as p of x, right? So next we will move for the next classification of the polynomials. Okay students, next we will know the definition of polynomials, right? Previously we learned that definition of a monomial, binomial and trinomial, right? Monomial means only 1 term, binomial means 2 terms and trinomials means 3 terms, right? Then what is a polynomial? A polynomial, it is also an algebraic expression only. It is also an algebraic expression which containing more than 3 terms, right? Which containing more than 3 terms. Maybe it may be containing 4, 5, 6 or so on till n types. Till n number of terms it may contain. Such type of algebraic expressions are called as here polynomials. Okay, we will see examples for the polynomials. Examples: x cube plus 4x plus x square plus 3x plus 1. Right? This is what an polynomial which containing 4 terms, means more than 3 terms it containing, isn't it? 1, 2, 3, 4. Then this is what a polynomial, right? We'll see one more example, second example, that is x raised to 4 plus 3x cube plus 2x square plus x plus 1. You can see here it containing 5 terms. Likewise, it can contain n number of terms. Then such type of equations or algebraic expressions are called as here polynomials. Okay, So we'll write the definition for the polynomial. An algebraic expression which containing more than 3 terms is called what? A polynomial. So then you can write an example for a polynomial which containing 6 terms also. That is third example I am going to give, that is y raised to 5 plus 3x raised to 3y raised to 4 plus 2y raised to 3 plus y raised to square plus y plus 1 is equals to 0. Right? This is what a polynomial. And we denote it as P of x. The notation to denote the polynomial it as P of x. How to read? It is P of x. We need to read it as P of x. Here P means polynomial. It is a polynomial which containing x variable. Did you all got? How to read it as P of x? We need to read it as. So how to denote the polynomial here? Example, P of x. Why P of x? P means polynomial, x means this polynomial containing x variable. So x here. If here you can see, this is a polynomial which containing y variable. So P of y. And here also, P of x is equals to what? This. Right? This is the notation for the polynomial. Okay. Now we can observe in these three examples that x, the equation or the polynomials, in these three polynomials you can observe that x is the variable in first polynomial, and here also in second polynomial x is called the variable, and in third polynomial y is called the variable. Right? Here variables are, in these three equations variables are, here it is x, here also x, and here it is y. Okay, and constants are here the numbers. If here it is nothing beside the x, means it will be always 1. That all you know. Okay, then 1, 4, 3, 1. These all are what? These are the constants. These are called as constants. In this equation also you can observe, here it is 1, 3, 2, 1 and 1. These are also what? A constants only. Right? Then if a number, if the constants are associated with the variables, you can see here, this is the constant which is associated with the variable, yes or no? Yes. Then it is called as what? Then this constant is called as a coefficient. Then it is called as the coefficient. Once again I will repeat. If a constants associated with the variables, then those constants are called as here coefficients. Okay. Then in exams they may ask you, what is the coefficient of x square? Coefficient of x square is 4. Right? And here also coefficient of x cube is 1. Coefficient of x is 3. And here coefficient of x raised to 4, that is 1. Right? Do you all get? Then coefficient of x cube it is 3. Then what is the coefficient of x raised to 0? Here it is, they have not written x. The meaning of this is the x raised to 0, it will be present. The meaning of the only the constant means there will be x raised to 0 will be present. The meaning of x raised to 0 is always equals to 1. Right? Instead of writing this 1, once again they have written the constant directly. When you multiply any constant with a 1, we are getting that constant only, isn't it? So they have not written x raised to 0, it is understood. Then what is the coefficient of x raised to 0? That is 1. Here also we can say the coefficient of x raised to 0 is. Once again, we'll recall variables, constants and coefficients. Constant means only numbers. Only the numbers besides the variables, right? And variables means x, y, z, whatever it may be. These are called as variables. Coefficients means the constants. The constants which are associated with the variables, those constants are called as here coefficients. Okay. One thing you can observe that in all these types of polynomial, means in monomial, binomial, trinomial and in a polynomial, one thing is common, that the power of the variables, they are all in a whole number. Yes or no? They are all in the whole number. Here it is only 1 is present. 1 means there will be x raised to 0 will be present. Right? X raised to 0 will be present. You can see here 3, 2, 1, 0. Yes or no? They all are whole numbers or not? Yes. So, here in all these 4 types, the power of the variable, it should be in a whole number or it should be in a positive integer, right? Or we can say they may be also present, powers may be also present in a positive integers. Positive integers means what? 0 does not have any sign. Yes or no? Only positive integers means 1. Integer means 0 will also come. Positive 1, positive 2, positive 3 and so on, right? These types of powers should be present for the variable, right? Then we can say that the given algebraic expression is the polynomial. Okay. Now, if the power is present either in a fraction form or in a negative integer form, means such type of polynomials, such type of algebraic expressions, we cannot call them as a polynomials, right? Their powers, the powers of the variables should be present in a whole number or in a positive integers, right? Such type of polynomials are considered as a polynomials. We'll take some more examples which are not considered as a polynomial here. We'll take, here I am going to take square root t. 7 into square root t plus 1 is equals to 0. Right? Here this is not a polynomial because as I told, the power of the variables should be in a whole number or an integer, right? But root t can be expressed as t raised to 1 by 2, isn't it? We are getting the power of the variable in a fraction or not? Yes or no? So again this is not a polynomial. If the square root is present for a constant means, then it can be a polynomial. Right? This is a polynomial because the square root is not present for the variable here. It is present for the what? It is present for the constant. Yes. And one more example. 7t plus square root 1. Again this is also what? A polynomial because the square root is present for a constant. Right? Okay, I have written note. First point, the power of the variable should be whole number or a positive integer, or it must be a positive integer. Okay, now let us know the general form of polynomial. General form of a polynomial. The general form of a polynomial is an into x raised to n plus an minus 1 x raised to n minus 1 plus so on again plus a1 x raised to 1 plus a naught. This is what a general form of a polynomial. Once again, I continue the general form here. Once again, I have written it here. This is what the general form of a polynomial. Here, a naught, a1, so on to till an minus 1, an, these these are called what? A constant, I told, right? These constants must not equals to 0. These constant must not equals to the 0. We'll write here where a naught, a1, a2, so on till an must not equals to 0. Okay, if these constants became 0 means, if these constants becomes 0 means, at that time we are getting a whole polynomial as a 0 polynomial. We'll write here one more statement. An are constants and an must not equals to 0, right? If an minus 1, an, so until, if these all constants became 0 means, we'll check it here, what will happen, right? If a1, a naught, a1, a2, so on till an, if these are equals to 0 means, we'll substitute 0 in this equation. What will come? We'll see. 0 into x raised to n plus 0 into x raised to n minus 1 plus so on. Again 0 into x raised to 1 plus again 0. We can see that a 0 is multiplied with a variable. Again we are getting 0 only. This term is also 0. Everything we are getting 0 or no? Yes or no? So if constants became 0 means, we are able to get a 0 polynomial here. Okay, if constants became 0 means, we are getting a 0 polynomial. That's why they have given a condition that an means these all constants must not equals to 0. We'll write here second note, if a naught comma, or we'll take a naught equals to a1 equals to a2, so on is equals to 0 means all constants became 0 means, we get 0 polynomial. We get the 0 polynomial. Okay, and it is denoted by p of x is equals to 0. Right? Sorry, only by 0. We denote it by 0. Okay. Now, I have written this point in a note form. First, copy down the definition of the polynomial, example, a general form of a polynomial, then note down this note, 1-2 points. Okay. Next, write the definition of a constant polynomial. Next, we will learn constant polynomial. A constant polynomial, it is a polynomial which containing only constants. Such polynomials are called as constant polynomials here. Okay. We'll take examples for the constant polynomials. As you all know how to denote the polynomial, that is p of x is equals to 2. Right? This is example 1. And example 2, p of x is equals to 3. Then example 3, p of x is equals to 53. Right? These are what? 2, 3, 53 are a constants or not? So this is called what? A constant polynomial. So we'll define the definition for the constant polynomial. It is a polynomial which containing only constant. constant polynomial. Right? This is about the constant polynomial. Right? If we'll take here example 4. If the polynomial containing the constant 0, if it containing the constant 0, then such type of polynomial are called as zero polynomial. Right? If a polynomial containing 0, then such type of polynomials are called as here zero polynomials. Again, we'll write the definition for the zero polynomial. The constant polynomial 0, this is polynomial, right? This is a constant polynomial 0 is called what? A zero polynomial. The constant polynomial 0 is called zero polynomial. Example, that is p of x is equals to 0. Right? This is an example for the zero polynomial.